Okay, the first thing we're going to be talking about are the properties of addition, properties of matrix addition. So let's go ahead and list them out. We will let A, B, C, and D be matrices. More specifically, we want them to be actually m by n matrices. And again, remember that we're using capital letters for matrices, and usually when we talk about vectors, which is an m by 1 or a 1 by n matrix, then we'll usually use a lowercase letter with an arrow on top of it. But capital letters for a standard matrix. So let A, B, C, and D be m by n matrices. Okay. A plus B equals B plus A. This is the commutativity property. In other words, it doesn't really matter which order I add them in. Just like if you add 5 plus 4 is 4 plus 5, matrices are the same thing. And again, we're presuming that these are defined. So if you have a 2 by 3, you need a 2 by 3. You can't add matrices of different dimensions. B, our second property, is the associativity property. So it says that if I add B and C, and then if I add A to it, I can actually do it in a different order. I can add A and B first, and then add C to it. Again, very similar from what you understand with the real numbers. It's perfectly true for matrices as well. Okay, I'm going to introduce a new symbol here. It's a little bit of shorthand. It's a reverse E with an exclamation point. It means there is a unique. So that means there is one. So there is a unique matrix, Rix 0, and I'm going to put a little bracket around it to make sure that it's this is the symbol for the 0 matrix, which consists of all entries that are 0. So there exists a unique matrix 0 such that A plus the 0 matrix equals A. And this serves the same function in matrices as the 0 does in numbers. So in other words, 5 plus 0 is still 5. This is called the additive identity. Additive because we're dealing with addition, identity because it leaves it the same. A over here on the left side of the equality sign, A over here on the right side of the equality sign. So it is called additive identity. Or more formally, with these 3 lines here means it is equivalent to, we just call it the 0 matrix. It's probably more appropriate. I'll more often be referring to it as just the 0 matrix or something like that instead of the additive identity. Okay, and our final, okay, once again our little symbol. There exists a unique m by n matrix. We'll call it D, such that, where should we put, let's put it over here. A plus D is equal to the 0 matrix. Call D minus A. So we'll refer to D as minus A. In other words, it's just the reverse. So if I have the number 7, well, negative 7, 7 plus a negative 7 is equal to 0. It gives me the additive identity for the real numbers. Same way, if I have some matrix A, and if I add negative A to it, I end up with the 0 matrix. Makes complete sense. And again, we're doing corresponding entries. Okay, let's do an example.